Have you ever tried to solve a visual puzzle, like a complex jigsaw or an abstract pattern match, that was almost impossible to describe in words? This paper examines how we can help AI models solve these hard-to-verbalize tasks by giving them a way to reason visually, without forcing everything into text. To understand the solution, we first need to identify the bottleneck in current large multimodal models. Standard architectures project images directly into a language space, which creates a bias where the model relies more on statistical text patterns than on the actual visual evidence it sees. Researchers have previously tried to fix this by feeding the model cropped images or helper visuals, but these approaches have significant downsides. They often impose human assumptions on what is important in an image and require expensive, non-scalable annotations. The authors propose a novel solution, the latent token. These are special tokens added to the model's vocabulary that aren't meant to be read as text words, but instead serve as a continuous visual scratchpad for the model. This figure illustrates the core mechanism called visual bottlenecking. By adjusting the attention mask, the researchers block the text generation from seeing the original image tokens directly, forcing the model to compress all relevant visual information into those special latent tokens. Sarah touched her chin. So, how do we actually teach a model to use this new Scratchpad effectively? Let's look at the implementation strategy. The training process is split into two distinct stages. First, they apply strict masking, where the latents must do all the heavy lifting. Then, in stage 2, they restore standard visibility so the model can integrate these new visual abstractions with the original image data. Technically, this is achieved efficiently by keeping the vision encoder frozen and only updating the language backbone using LoRa. The researchers found that adding exactly 16 latent tokens provided the optimal balance between reasoning capacity and computational overhead. Now that we understand the architecture, does this implicit reasoning actually lead to better performance? The attention maps in this figure prove that the model isn't just guessing. You can see the latent tokens explicitly attending to task-relevant regions, like the motorcycle or the semantic definitions in the images, without ever receiving direct supervision on where to look. The results are impressive, with the method outperforming the state-of-the-art Mirage baseline by 20% on some tasks and jumping 12% on jigsaw puzzles. However, the trade-off is interpretability. Unlike text-based chains of thought, these latent tokens are effectively black boxes to human observers. To learn more, head to emergentmind.com.